Alright, imagine this. Two quantum computers sitting 6 feet apart in a lab suddenly start working together as if they're one. Sounds like science fiction, right? But thanks to a stunning breakthrough from Oxford University, quantum teleportation between quantum computer chips is now a reality. I know teleportation gets thrown around a lot, but this one? It's the real quantum deal. So, let's break down what actually happened. A team of scientists, led by physicist Dougal Main, set up two separate quantum chips. Their challenge? Getting these chips to talk, not by running a cable, but by teleporting the quantum state of a qubit from one chip to the other. Not the qubit itself, but its super fragile quantum identity, that weird ability to be both 0 and 1 at once. How did they pull this off? It's all thanks to quantum entanglement. They use two types of qubits, network qubits, which are like communication officers optimized to send and receive signals, and circuit qubits, which do the actual number crunching. First, they entangled the network qubits on each chip. Then, using a quick burst of classical data, think 2 bits, the team transferred the quantum state, almost like beaming someone's mood across the room, and made the two chips act as if they were one. The results? Pretty impressive. The recreated quantum state had an 86% match with the original. That's high enough to build a working logic gate between the chips. Then, just to show off, the team ran Grover's search algorithm, one of those classic quantum computer routines, and it returned the right answer 71% of the time. Not bad for a first try. And get this. The main hiccups weren't from the teleportation link itself, but from small imperfections in the hardware. So the teleportation channel is solid. But why does this matter? Here's the big deal. Instead of trying to build one gigantic, error-prone quantum computer, we can now connect lots of smaller, more reliable ones. Each module can be swapped out, upgraded, even repaired, without taking down the whole system. That means more flexibility, fewer errors, and a real path toward scaling quantum computing. Looking ahead, this breakthrough is a huge step toward building a quantum internet. Imagine secure connections linking quantum computers and sensors across cities, even continents. We're talking about a future where things like drug discovery, database searches, and encryption are revolutionized. There's still work to do, making those entangled pairs faster and more reliably, bumping up the fidelity, and adding more qubits into each module. But the foundation is there. So next time you hear quantum teleportation, remember, it's not just for sci-fi anymore. It's happening right now, and it could change everything about how we compute.